Now let us today's class. Let us discuss about. Let us solve a problem based on designing a FIR filter using Fourier series method. The problem given is he asked to design a low pass FIR filter. So with 5 stages and sampling time is given 1 millisecond and frequency cutoff frequency is given in 200 hertz. So it is now what we understand now. So since it is in hertz, so it is linear frequency and sampling time is 1 millisecond, that is 10 power minus 3 seconds. Now we know sampling frequency is inverse of sampling time, that is 1 by 10 power minus 3, that is 10 power 3 hertz. So from the sampling time we found the sampling frequency, we have cut off the linear frequency, and we say number of stages are 5, so n is equal to 5. So when n is equal to 5, total number is 5. Now when I shift to left side and right side, n minus 1 by 2 to minus times and plus times, so n minus 1 becomes now 5 minus 1, 4 by 2, so n minus 1 by 2 2. So plus n minus 1 by 2. If I put n is equal to 5, 5 minus 1, 4 by 2, that is minus 2 2, so plus 2. So this minus 2 to plus 2, so or the if I take time limits, minus 2, minus 1, 0, 1, 2, these are the 5 values, or the 5 stages or 5 samples he is asking. So this is n, so this is small n, where this number of samples n is equal to 5, right? Now what we observed here, so you want to design this filter. So what is for designing this filter? Now what we observe, what we know, the first step is capital HD of e power j omega is nothing but, so here omega c we know it is 2 pi cutoff frequency divided by sampling frequency, that is 2 pi cutoff frequency is 200 hertz, sampling frequency we got is 1000. So this is 1 by 5, 2 by 5 is 0.4 pi times radians per second, 0.4 pi radians per second. Now omega c I have cutoff frequency. Now I am designing a low pass filter. The low pass filter, how can I take a low pass filter now? So this is omega, now this is minus pi, this is plus pi. Now our cutoff frequency is minus 0.4 pi to 0.4 pi. This is we know it is omega c. We know it is minus omega c. Minus omega c is minus of this thing. Omega c is 0.4 pi. So between this cutoff frequency, it is a low pass filter I am designing. So low pass filter between this minus omega c plus omega, amplitude is 1. Between minus pi to this value, this is amplitude 0. Between 0.4 pi to pi, the amplitude is 0. So now this is the desired transfer function e power j omega. So how can I write now these values? E power j omega is 1. In the limits, I can write modulus of omega c is less than, omega is less than modulus of omega is, omega, this implies omega is lying between minus omega c to plus omega c, and this is 0 for modulus of omega is greater than omega c. So greater than omega c is nothing but what? For omega greater than omega c and for omega less than minus omega c. So for these values, okay, this value is 0, this is 0, right? So this is the transfer function, desired transfer function, capital HD of omega, what we got in first step. What is our second step? What we try to do? We find HD of n. How do you get HD of n? Inverse dTft of this capital HD of e power j omega. So inverse dTft we know simply formula is 1 by 2 pi times integral minus pi to pi e power, minus pi to pi capital HD of e power j omega into e power j omega and d omega. Now here it is 1 by 2 pi. Now limits Now hd of e power j omega is only between minus omega c to plus omega c. Okay, so it is instead of minus, this only between minus omega to plus omega c. You don't want from minus pi to pi. If I take this minus omega c to plus omega c, I take hd of omega value is 1. So e power j omega n into d omega. Right? So once we get value, let me integrate e power a omega is nothing but e power j omega n by omega coefficients is jn. Now limits are omega is equal to minus omega, omega is equal to plus omega. Outside I have 1 by 2 pi as it is. Now if I see, if I substitute 1 by here, 2 pi jn, if I substitute the upper limit, it is e power j omega cn minus, if I substitute lower limit, e power minus j omega c into n, because upper limit is omega c, I substitute upper limit omega c. Lower limit is minus omega c, lower limit is also minus omega c, we substituted. Now e power j theta minus e power minus j theta, I can write by 2j if I take it here. So finally what we can write, 1 by phi n if I write, now it is e power j omega cn minus e power minus j omega cn by 2j. So this is nothing but cos omega n, cos omega cn divided by pi n. Now we have seen it is e power j omega cn minus e power minus j omega cn by 2j. So this is cos, it is cos omega cn by pi n. So omega c value, we know omega c is nothing but 0.45 radians per second. Let me write cos 0.45. Okay, 4 pi, this is omega n by pi n. This is hd of n, right? Now once we get this infinite impulse response, now calculating, put n is equal to 0. So when I put n is equal to 0, hd of 0 if I want. When it is 0, I can write a limit n tends to 0 cos 0.45 n by, okay, so pi n. Well, what we formula we know, standard limit formula, limit theta tends to 0. So this is, sorry, it is pi 2j. 2j it is not cos, it is sine. It is sine. It is sine. Okay, sine omega c, right? So now we know limit theta tends to 0, sine theta by theta is 1. So if it is theta, now if I want to make it theta, what is deficient here? 0.4 is deficient. Let me multiply, divide 0.4 and let me multiply 0.4. Right? Now if I take this 0.4 outside, now if I take 0.4 outside, it is limit n tends to 0. So sine 0.4 pi n by 0.4 pi n, sine theta by theta form. So this is sine theta by theta is 1. So I got this sample function at 0, h of 0 value is 0.4, this coefficient. Then let us try to find what is our third step. Now third step, step 3 is, let us try to find h of n. H of n is nothing but whatever hd of n I got, whatever hd of n, we try to take n is from the limits. What is n minus 1? In the starting step only we have taken n minus 1 by 2 to, so minus of n minus 1. Minus n is equal to, capital N is equal to 5 stages given. 5 minus 1, that is 2. 5 minus 1, 4 by 2 is 2. 2. This is again 2. So n is from minus 2 to plus 2. So n is from minus 2 to plus 2. If I substitute, what I try to get now, h of n is nothing but what are the coefficients I will get? All the coefficients from minus, directly I can write, we will get the coefficients from, that is h of minus 2, h of minus 1, so that is 0, h of 1 and h of 2. We discussed now, this is symmetrical about origin 0. So whatever the h of minus 1 value and h of 1 value, since it is symmetrical, these values are equal. and h of minus 2 value and h of 2 values will be equal, right? So already we got h of 0 value. Now h of 0 already we have, it is 0.4. Let us try to find what is h of 1 and h of 2. Once I get h of 1 is nothing but h of minus 1, h of 2 is nothing but h of minus 2. Overall, if I find next two coefficients for this filter, automatically other two coefficients we will get, which are equal to this, since this is symmetrical about, because we know this is h of n, nothing but h of minus n. We know the filter is symmetrical about, this is the symmetrical about n is equal to 0, right? Okay, now how to get, we'll try to find this coefficient values. Now we have seen h of n value we got is sin 0.4 pi n by pi n, and we substituted n is equal to 0, and by sin theta by theta form we got 0.4. Now we need to find h of 1, h of 2, by default h of 1 because h of minus 1, h of 2 because h of minus 2. So here if I put, if I take this as some equation 1, so put the n is equal to 1 in equation 1. So what I get, this is h of 1, in place of n I am substituting 1. This is sin 0.4 pi into 1 by pi into 1. So if I substitute now in terms of, remember when I am calculating, in calculator when I am taking, please see such that the calculator is in radians mode. So this is very important, right? Because pi radians I am taking. By default, calculator shows degree values, convert into radians mode and calculate. When I calculate this value, it is 0.3027. Now similarly, put n is equal to 2 in equation 1. Now what I will get when I put n is equal to here, this h of 2 is nothing but sin 0.4 pi into 2 by pi into 2 overall divided by. So this value if I observe, this is 0.0935357, or you can say 3 point. Now this h of 1 is nothing but h of minus 1, this h of 2 is nothing but h of minus 2. So therefore, so FIR filter coefficients are h of what are the FIR filter coefficient? H of minus 2, h of 1, h of 0, h of 1, h of 2. H of minus 2 is nothing but h of, this is 0.0935, h of 1 is 0.3027, h of minus 1, this is 0.4, this is again 0.3027 and 0.0935. These are the filter coefficients I got. Once I get filter coefficient, what is the next step we are taking? Step 4 is what we are trying to take. Now we are trying to find the Z transform. How do we get Z transform now? H of Z is nothing but summation. So directly we have the formula. Let me write the formula directly. H of 0 plus summation n is from 1 to n minus 1 by 2. N minus 1 by 2 is nothing but 2. I got n minus 1 by 2. We already n is 5. 5 minus 1 by 2 is 2. So 1 to 2. This is h of n outside. So z power n plus z power minus n. This is what we have seen. Now if I expand, now what we get? This is h of 0. N is equal to 1. If I substitute, now it is h of 1 multiplied by z power 1 plus z power minus 1. Now this is h of 2. When I put n is equal to 2 now, next 1 to 2 I am getting, now n values are from 1 to n minus 1 by 2. N minus 1 by 2 is 2. So if I put 2 now, second value in place of n, h of 2. Now bracket z power 2, here also let me substitute n is equal to 2, z power 2, z power minus 2. So this is nothing but h of z. Once I get h of z, what is our next step now? What is our second step, or directly we can write our next step. What is our next step? I am shifting to make the signal causal. Shifting in time domain is nothing but multiplied by, so h dash of z should be multiplied by h dash of z is nothing but this h of z. H of z is multiplied by z power minus of n minus 1 by 2. What is z power? This is nothing but z power minus 2 into capital H of z. So that is h of capital H of z value. We have this equation now. That is z power minus 2 outside. Now this is h of 0 plus h of 1 into bracket z plus z inverse plus h of 2 into bracket z square plus z power minus 2. If I take this, multiply this z power minus 2 to each term, now here there are 5 terms. If I multiply, therefore h dash of z is nothing but, now when I multiply, let me write in order. Now this is minus 2, this is minus 2 plus 1 is minus 1, so minus 2 minus 1 is minus 3, minus 2 plus 2 is 0, then minus 2 minus 2 is minus 4. Now if I write in order, so this is 0 term I am getting, so this 0 term is multiplied by this, that is h of 2 into z power 0. Now z power, now after that z power, let me write from negative only starting, z power minus 2, z power minus 3, z power minus 4. Let me write from z least term, z power minus 4. Where is z power minus 4 term? Z power minus 4 multiplied by this h of 2, right? Next, where is z power minus 3 term? Z power minus 1, z power minus 1. This is multiplied by h of 1. So this is h of 1 multiplied by z power minus 3. Now where is z power minus 2 term? So minus 2, this is directly, this is z power minus 2 first term into h of 0, right? Next, where is z power 1 term? Minus 2 plus 1 is, this is h of 1 into z power 1. Now next, minus 3, minus 4, minus 3, minus 4, minus 3, minus 2, minus 1 we missed here, minus 1, minus 1. Where is minus 1 is h of 1. Next, z power 0 term. Where is z power 0 term? Minus 2 plus 2, that is here h of 2 into z power 0, right? So this is nothing but so overall, see now the coefficients are from minus 2 to 0. So coefficients are from minus 2 to 0. To make it causal, I am shifting this right side by 2 units. This negative I want to make 2 units. When I make 2 units, I am adding 2 values to each value. When I add 2, it becomes now 0. When I add 2, it becomes 1. When I add 2 for 0, it is 2. When I add for 1, it is 3. When I add for 2, it is 4. So therefore, so z power minus 4 coefficient is nothing but this is h of this is z power minus 4, whatever the values we got, h of 2, h of 1. Let me substitute our values now. That is h of 2. What is the h of 2 value? Already we got h of 2 value. This is h of 2 value. H of 1, h of 0, h of minus 1, h of minus 2. Let me substitute that value. This is 0.0935 into z power minus 4. Now this is h of 1. H of 1 is 0.3027 into z power minus 3 plus h of 0 is 0.4 into z power minus 2. Now this is h of 1 already we got same 0.3027 into z power minus 1, and last one is 0.0935, right? So basically when I am taking negative powers of z, so negative powers of z is a causal system. So if I write in order, now what we have seen now, h dash of z value, now we shifted now, right, by 2 units. So shifted by 2 units, this is for n is equal to 0, h of 0. So this is h of 1, n minus n, z power minus n means n is 1 here. So 1 means h of 1, this is h of 2, h of 3, h of 4. Whatever the values we have earlier, now we can see now this is our new value. So new coefficient, this is h of 0, this is the new h of 1, so or h dash of 0, h dash of 1. So I can take this as h dash of 2, this is h dash of 3, this is h dash of 4. Because earlier whatever we have from minus 2, it's shifted to 0, minus 1 is 1, like this it's shifted. So this is h dash, and dash I am representing by new values, new shifted coefficients I am writing. Why I am shifting to right side is to get a causal sequence. The next, the last step is step 6. Let me find frequency response. So how do you get magnitude of this h of e power j omega? Is magnitude is nothing but What is the formula we wrote? H of 0 plus summation n is from 1 to n minus 1 by 2, that is nothing but 2. So 2 times of h of n into cos omega n. Now if I expand now what I am getting, this is h of 0. When I put n is equal to 1, 2 times of h of 1 into cos of omega into 1. Now 2 times of h of 2 into cos of omega into 2. Now one important point to be noted. So modulus of this is modulus of h of e noted is, now here whatever the values you are writing, these values, this h of 0, h of 1, h of 2, don't consider the new values, because in the transfer, in the frequency response what I am taking the originals only. If I want to shift now, I have to multiply here this by, I have to multiply here it by z power minus of in minus 1 between, I have multiplied by z power minus 2 terms. Okay, so instead of multiplying and again taking that value and again taking this new values coefficients here, anyway it is same. The old values h of 0, what is our old h of 0, original h of 0, this one new values after shifting I am denoting by dash to avoid confusion. So I am writing this h is nothing but old values. H of 0 is nothing but 0.4. Now 2 times of this is 0.3027, this is cos omega, this is 2 times of 0.0935 into cos 2 omega. That is now finally modulus of h of e power j omega is 0.4. This is, if I multiply this is 0.6054 into cos omega into cos omega. Now this is 0.0 what I can write now, 0.187 into cos 2 omega. Now I want to plot this graph. How to plot this graph now? Let me take omega and let me write this is modulus of h of e power j omega. Okay, modulus. Now let me take some values and plot. Suppose 0, which is our values, I can, our wish values. It means suppose pi by 18, pi by 2 pi by 18, 3 pi by 18, 4 pi by 18, like this 5 pi by 18, right? Again remember, when I substituting here, now omega is nothing but 0. When I substitute omega is equal to 0, so whatever values, suppose it is 1.124. now this is 1.0, approximately I am taking 1.09. now this is I think 1.41. this is 1.12, approximately I am trying to say. This becomes 0.9 approximately. This becomes nearly 7, that is 0.89 approximately. This is 0.6, that is 0.65 or 0.5 approximately I am saying. Approximately you can see this in calculator like that. So whatever the values we get now, if I try to plot this now, this is omega. Now this is modulus of h of e power j omega. For 0, this is pi by 18, this is 2 pi by 18, 3 pi by 18, 4 pi by 18, 5 pi by 18, like this if I plot. Now this is approximately, the graph is so decreasing, the graph is slightly decreasing like this, and at some point of after some point of cutoff frequency, now you can find some ripples are happening. We can find some ripples. So this is, you have to observe now, this is in pass band, this is in pass band, and this is ripples is happening in stop band. Now what is, this is the observation of the graph. Now these values, whatever you can take this some values, okay, and you can write these values and you can plot. Fine. So this is the way of solving a problem in using designing a low pass FIR filter for 5 stages. So he has given linear frequency, cutoff frequency FC is 200 Hertz and sampling time is 1 millisecond, right? From that we have designed a low pass filter, and we have seen the original coefficients, and after shifting by 2 units to make it causal, what are the new coefficients, filter coefficients, then what is the frequency response we have seen, and we are trying to plot this graph of this frequency response. Okay, so similarly, now let me give you a small let me give a small task. Now I want to design a low pass filter. Sorry, please, you can design a high pass filter whose coefficients are from minus pi by 2 to, so this is 1. Okay, and this is 0 between minus pi by 2 pi by 2. So this is a high pass filter HD of e power j omega. Now let us consider capital N. It is the n stage. It is 11 stage. If you consider for 11 stage, let us you please try to solve a high pass filter. Design a high pass filter whose we have, these are the cutoff frequencies given, minus pi by 2 to plus pi by 2, and for 11 stage 11 stage I want to design a high pass finite impulse FIR filter. Now you will find, when I plot finally, you will find these ripples in pass band, and you will find a constant graph in stop band. If you please try solve the same model, try to solve this. Okay, thank you. Now regarding the to get more to have some interactive session, or you have more doubts and all, you can please contact you can contact me to this number 98850 sorry 9246 777 You can contact me to this number. You can just contact me to this number. If you have any doubts, I am ready to solve it. And if you like this video, please subscribe to get further videos. Thank you very much.